After the discovery of the Oklo reactors, many scientists wondered whether such a phenomenon could happen again. It's important to remember that even though they are called nuclear reactors, these ancient reactors weren't anything like the ones humans built. They were simple, unplanned events that happened naturally. There wasn't any containment structure or cooling system. So if these natural reactors could contain their waste products, why couldn't modern human reactors? Scientists started searching for other sites where similar natural reactors might exist. It took them 10 years, but in 1982 they finally found another potential candidate. The Cigar Lake deposit in northern Saskatchewan, Canada, located about 100 kilometers north of the town of Denari Beach. Cigar Lake had already been mined for uranium several times. In 1968, geologists found high levels of radioactivity in one of the shafts. But what they found out in 1982 was that the entire deposit was permeated with alpha particles, indicating the presence of a large number of nuclear reactions. At first, they thought the Cigar Lake deposit might be younger than Oklo, but radiometric dating revealed that it was more than twice as old, at 2 billion years. And just like Oklo, the amount of uranium had decreased significantly, suggesting that the uranium had been used up by nuclear fission. But unlike Oklo, the Cigar Lake deposit hadn't just been used up, it had exploded. When the researchers examined the site, they realized that the explosion had broken through the rock like a massive earthquake, creating huge cavities. Further drilling revealed that the explosions had actually created 3 large interconnected craters, each about the size of a house. Each crater had a different shape and was filled with a different type of material. The largest crater was filled with pulverized rock that had been fused together by the intense heat of the explosion. The middle crater contained pieces of country rock that had been blasted from the surrounding area. And the smallest crater was filled with a black, glassy material that looked like obsidian. It was clear that a chain reaction had taken place here, but exactly what had happened remained a mystery, using computer models. The team was able to piece together what had occurred at Cigar Lake. They concluded that the original deposit of natural uranium had been 25 times larger than the one in Oklo. The chain reaction had consumed most of the uranium and produced an enormous amount of heat, which had caused the rock to explode outward. But instead of just blasting the rock apart, the explosion had melted parts of the rock and fused them back together, creating a natural nuclear reactor. The explosion had also created a cavity that allowed groundwater to flow in, and this water had leached out the remaining uranium, stopping the chain reaction. Over time, more water had seeped in and deposited minerals in the cracks, sealing the reactor off from the rest of the deposit. But what had triggered the explosion? Unlike Oklo, the Cigar Lake deposit didn't have any water to moderate the neutrons and keep the reaction under control. In fact, the whole area was incredibly dry. The answer turned out to be even more bizarre. The chain reaction had consumed all the oxygen in the surrounding area, turning it into a massive underground fuel cell. The explosion had been so powerful that it had blown through the top of the deposit and created an opening to the atmosphere. Oxygen from the air had rushed in and reignited the deposit, causing it to explode once again.
Ow.
These 2 discoveries raised more questions than they answered. How common were these natural nuclear reactors? How long did they last? And what other effects did they have on their surroundings? Fortunately, the search for answers has been slow. Natural nuclear reactors are obviously not something that we can create or study directly. While there have been some promising leads, nothing has come of it yet. Perhaps one day we will find more of these natural reactors and learn more about how they work. Until then, we can marvel at the incredible power of nature and the strange ways that the universe works.